Now we'd like to find some derivatives using implicit differentiation. We're going to start with some rather basic functions, ones that we actually could differentiate explicitly. So in fact, actually this one I'm just going to real quickly do explicitly. Right, solving for y, I could rewrite that as y equals 1 over x, or x to the minus 1. And of course, we know by the power rule that that would be minus 1 x to the negative second, which would be negative 1 over x squared. Now I'm going to use implicit differentiation so we can see that it actually does give us the same answer. Now for a function like xy equals 1, unless you were told, hey, use implicit differentiation, you're probably not going to want to bother with it. It's a little quicker to rewrite it, use the power rule. But here's how implicit differentiation works. We start by differentiating both sides with respect to x. So here we have xy, but xy is a product. X is x, and we're assuming that y is something that's dependent upon x. So we do the derivative of xy over here. We're assuming, hey, that that's a product there of two functions. So we have to use a product rule. So that would be x times the derivative with respect to x of y plus y times the derivative of x with respect to x of x. And that'll be equal to the derivative of 1, but we know the derivative of 1, since it's a constant, is 0. Now the derivative of y is just dy dx. So we have x dy dx plus y equals 0. And so now we can solve for dy dx, right? Treat it as if it's just its own variable. So subtract y from both sides. Get x dy dx equals negative y. Divide both sides by x, we get dy dx equals negative y over x. They say, well, how in the world does that look like negative 1 over x squared? Well, because we are able to solve this equation explicitly, we know that y is equal to 1 over x. So substituting that in, so we know that y is equal to 1 over x. So substituting that in, we get dy dx is equal to 1 over x, and, negative 1 over x because it's negative y. And of course, simplifying that gives us negative 1 over x squared. The same answer we got using explicit differentiation.